This model question is regarding the Earth's atmosphere, and more specifically it's related with the Earth's magnetic field as well as like the height of the troposphere. Now let's first of all let's take a look at the magnetic field of the Earth. Earth is a magnet and it's having north magnetic pole as well as south magnetic pole, and we got the magnetic field lines extending from the north magnetic pole to the south magnetic pole. I mean, in the sense, field line means like the field where a magnet can exert its influence, right? So since Earth is acting as a magnet, it's having its own magnetic field lines, and that actually is very important for the life to survive on the Earth. This magnetic field, or you can say magnetic shield, protects Earth from the solar flare or the solar wind coming from the sun. Now the solar flare, or like say solar wind, it means like the particles which are coming from the sun, which are coming with high velocity, right? Like if it directly collides with this Earth's atmosphere, like the surface and everything, the life can be wiped out. Okay. Now the Earth's magnetic field actually prevents the solar wind from reaching the Earth's surface. Now the way the magnetic field is arranged, right? These charged particles coming from the sun will get deflected, and more these particles, right? More particles will be deflected or diverted towards the Earth's north magnetic field as well as south magnetic field, right? So in the sense, since we are having this magnetosphere, or this part of the atmosphere we call it as magnetosphere, where the Earth as a magnet can exert its influence, right? So this magnetosphere, or like the magnetic shield, protects Earth from the harmful particles coming from the sun. Okay. Now this results in a physical phenomenon in the Earth which is called as aurora formations, right? There are two terms, aurora borealis as well as aurora australis, right? Now this, aurora means like the sky will be appearing in different colors, right? Now this particular phenomenon cannot be visible, is not visible in the equatorial region, rather than we have to go near to the north magnetic pole as well as the south magnetic pole to witness this event, and it's related with this diversion of the charged particles towards the polar regions, right? And before discussing how they are formed, now let's take a look at different layers of the atmosphere. Now the Earth is having different layers in the sense it's classified into troposphere, stratosphere, mesosphere, thermosphere, as well as exosphere. Almost all of the weather events and everything is limited to the troposphere, the climatic phenomena, the cloud phenomena, or the weather events, everything is limited to the troposphere, right? And there is one particular region in the thermosphere, like which is also called as ionosphere, right? Ionosphere. And the ionosphere, from the term itself, is having more ions. Ions in the sense they are charged particles, right? So consider this like the charged particles which are deflected from the sun towards, which are diverted towards the poles, will interact with the ionosphere in the Earth's surface, Earth's atmosphere, and that results in the creation of aurora formations. Like, so how the aurora is created? When the solar wind is diverted towards the north magnetic pole as well as the south magnetic pole, it interacts with the charged particles in the ionosphere, right? Which is a layer in the Earth's atmosphere. And that creates, right? That creates, or that gives different color to the sky. Okay. Now let's discuss regarding the troposphere. As I said, all the climatic phenomena and weather events, they are limited to the troposphere, cloud formations and everything, right? So this picture is showing the troposphere, the height of the troposphere, and this is a surface starting from on the right side. You can see the equator, and this is the northern pole, right? It's more like an elevation picture, right? It's not a satellite image, rather than we are seeing an elevation. So near to the equatorial region, what happens is that we are having upward moving wind, right? In some other videos we have covered the atmospheric circulation. We are having the Hartley cell, Ferrel cell, as well as polar cell, right? It's a part of meridional circulation of the atmosphere. So the regions near to the equator, right? Near to 10 degree north to 10 degree south latitudes, will be having convergence of wind and more amount of insolation taking place in these regions. And for that reason, we'll be having upward moving wind. Okay. And this region, we are having the equatorial low pressure belt. So wherever we are having low pressure belt, we'll be having upward moving wind. And in this equatorial regions, right, since the since we are having the upward moving wind, the atmosphere will be pushed to increase its height. So for this reason, we will be having the height of the troposphere maximum over the equator. At the same time, if you are considering the polar regions, like the extension of the atmosphere is less. See here, the average height comes somewhere near to 9 kilometers, and in the case of the equator, it comes near to as much as 18 kilometers, right? So the height of the troposphere, or generally the height of the atmosphere, is not same throughout all the latitudes, right? It is different. In the equator, it's having more height because we are having the vertical movement of wind, and in the polar regions, since we are having downward movement of the wind, the extension is very less, right? So let's go back to the question. So the two statements which were given in the question, the first one, the Earth's magnetic field diverts electrically charged particles from space towards its poles, which is true, right? So the first statement is correct. And the second statement, the height of the troposphere decreases during summer and it increases during the winter. Now if you have observed the explanation, right, why in the equatorial regions we are having more height of the troposphere? Because we are having the convergence of wind, and we are having convection, or we are having the more amount of sunlight or insolation coming to these regions, right? For this reason, we are having like the upward movement of wind increasing or resulting in the higher height of the troposphere, right? Now think about the summer season as well as winter season. During summer, we will be having more insolation, right? So we have covered the seasons in some other videos. So like if northern hemisphere is experiencing season, right, summer season, at the same time, the winter season will be experienced by the southern hemisphere. So when we are having the summer season, more amount of insolation or more amount of sunlight will come from the sun. And for that reason, the height of the atmosphere, relatively, it will be higher during the summer season. And during the winter season, it won't be as extensive as the summer season, right? So when is the height of the atmosphere higher? During the summer season. And where is the height of the atmosphere higher? Is it in the equator or the poles? It's over the equator, right? So the second statement in the question, the height of the troposphere decreases during summer. So it's saying like the height is decreasing during the summer, which is wrong. And it increases during the winter. So this statement is wrong. Like instead of the decreasing, it should have been there, increases, right? And here, if it was decreasing, then the statement would have been true. So since it is not the case, the second statement is wrong, and here the answer is like A, which is 1 only. Only the first statement is correct.